So in this question, guys, we are asked to prove the sine rule for triangle MNP with MS perpendicular to NP. So you have to draw the triangle for yourself so that you can make this thing simple. I already drew my triangle. As you can see, we have the triangle MNP, which is perpendicular with MS perpendicular to NP. So you can extend NP, then draw MS to be perpendicular to that NP line, right? So it's now perpendicular, as you can see, MS. So I name that line H, which is the height of that line, right? So step one, you're going to use the sine rule ratio to express the angle in the triangle in terms of the length side. So let's say in triangle MSN, what do we have? MSN, you can see the triangle is the triangle that we are not given. So MSN, you can see it's MSN. This is the triangle, right? So in this triangle, what do we have? We have sine angle N2 is given by H, which is the opposite, over the P, which is the hypothesis. We already spoke about this. Therefore, you can simplify this further and say H is equals to P sine N2, sine angle 2, right? And we can also realize that angle N2 is equals to 180 degrees minus N1, as we can see that. So this is because we have angles on a straight line. We know this rule. You have to write this, guys, because they put marks for this. Angle on a straight line. We can therefore see that, okay, since N2 is this, we can replace this here. Then we have, therefore, H is equals to P sine N2, which is 180 degrees minus N1, angle N1. So we already know that 180 minus N1 sine is in the second quadrant. So you can write it in this form. We know this. We have done this. Sine N1. It's positive because it's in the second quadrant. Therefore, H is that, right? So let's go to the other triangle and say in triangle MSP, the triangle MSP, triangle MSP, because we want to use the common length, which is going to be MS. We want to use that. We want to have the common side that we can use. So we notice that sine P is equals to sine P. This one is going to be opposite, which is our H, then divide by N, right? So you can just say, therefore, H is equals to N sine angle P. That's that. So since we have H here and H here, we can equate both of them and have P sine angle N1 is equals to N sine P, angle P. Then we know that we have to divide the like term so that it can be sine N1 divided by N is equals to sine angle P divided by small letter p, or you can write it like this. N is equals to sine angle N1 is equals to P, which is going to be sine angle P. So this is your answer, or this one. It's going to be your answer for this solution. So that is how you prove that the sine rule for triangle MNP with MS is perpendicular to this. We prove the sine rule like that because we can see that this is the formula for the sine rule, both of them. So that was the answer for this question. Thank you.